Okay, so this is the last of the three solutions videos. This is on the polynomials. I'm going to go pretty quickly through this because it's the most recent unit we've done, and also because I'd like to try and get this as the last video and try and wrap this up in 15 minutes. This is all going to be on the non-calculator, so no TI Inspire for any of these. Okay, somewhat difference of the following involves adding and subtracting like terms. And so in this case we've got to start by identifying our like terms, adding and subtracting. When you add and subtract like terms, you do not alter the powers because it's not multiplication or division. And so we have 1x cubed minus 3x cubed is minus 2x cubed. We have a plus 2x minus 5x plus 4x is going to leave us with plus 1x, and the other two terms have no like terms, and so I'm going to leave them as is. Same procedure for the second question. What we've got to know for like terms is that they must have the same letters, bases, and the same powers. And so we're looking for a y squared with a zx, so we have another one over here, and then we have an xyz and an xyz over here. Add and subtract the like terms. We have minus xyz plus xyz is going to cancel. We have 2xy squared z minus 2xy squared z. The order of the letters doesn't matter. Those are going to cancel, and so we're actually just left with x squared y squared z. Okay, next one. This is, and look carefully at the instruction, this is a simplify question. Sum or difference of the following, and so do not distribute the terms in the first parenthesis by the terms in the second. The only thing being distributed is the minus sign. And so the first step of this is simply to drop the parentheses, and in so doing you'll notice we changed the signs of both of the terms in the second bracket because they had a minus outside. Now the problem is the same as the previous ones. I've got an x squared minus an x squared, which is going to cancel. I have plus 4 minus 2, and so I have minus 3x, which can't combine with anything, and plus 2 as my final answer. Okay, question 4, product. Now it's distribution, term outside by each term inside, and so we have 6x cubed, we're adding powers, times y, plus 2x cubed y squared, and the last term, beg your pardon, not plus, but in fact minus 6x squared. Okay, moving on. Once again, we're going to find the product, and so in this case, same concept as before, but now we have a binomial times a binomial, so we're going to use FOIL or distribution, or our rainbows, if you will. And so we have x by x is x squared, x by minus 6x, plus 6 by x is plus 6x, plus 6 times minus 6 minus 36, and the next step is of course to add and subtract like terms. The middle two terms are like terms. They happen in this case to cancel each other out, and so that is our final answer. Key step when you square a binomial is to realize that it is in fact a distribution problem. So you write it out as x plus 7, and then we'll use our rainbow once again. So x squared plus 7x, a little bit too fast, x squared plus 7x plus 7x plus 49, and like terms in the middle, x squared plus 14x plus 49. Okay, as before, straight distribution problem, and we have our so-called rainbows. This time added level of difficulty because the first term has a 3 as well, so we just got to watch out for our values. So we have 3x squared minus 3x plus 4x minus 4. Once again, the middle two terms are like terms, and so we need to simplify. Minus 3x plus 4x is plus 1x, or just plus x, and then our minus 4. Once again, same concept. We are using the rainbows, but this time with a binomial times a trinomial, we're going to in fact end up with 6 terms in the initial answer. And so we have x cubed minus 5x squared minus 3x, and then we need to do the same thing for the second term, minus 2x squared plus 10x, because a minus times a minus is a positive, and for the same reason plus 6. And last piece of the problem is to identify any of our like terms, of which we have two pairs, and so we have x cubed remains unchanged, minus 5x squared minus 2x squared will give me minus 7x squared, minus 3x plus 10x is going to give me plus 7x, and plus 6 is left over. Alright, moving on. We are now moving into factoring, and you are told this is GCF, which means it's the term or the number or the combination of the two that that belongs to all of the terms. So in this case we have 12, 20, and 18. We can remove what can we remove? 3, 4, we can remove 2 from each of those terms. We also have x cubed, x squared, x5, and so I'm going to remove an x squared. That will leave me, when you remove, it's the reverse process of distribution, and so distribution is multiplying. This is effectively dividing, so we're going to divide each of these terms by the GCF, and that'll tell us what's left behind. So that should leave us with 6x, that should leave us with 10, but the x squared's completely gone, and this will leave us with 9 x to the power of 3, and the key is if you look inside the parentheses, the terms no longer have anything common, and that confirms that we've removed the greatest common factor, not just a common factor. Okay, similar kind of question, 4, 12, 3, we can't remove anything in terms of numbers. We can remove, we have an x cubed, an x squared, and an x, so we can remove an x. And in fact, if you look at this n term here, they've got an x and a y and a z. All of the terms do, but we can remove no more than x, y, and z. And so what that will leave us with is 4x squared, y1, and the z is gone, plus 12x1, y2, and the z is gone, minus 3, and all three of the terms are gone because they're all accounted for outside. Okay, small application question. This is also a GCF question. What you need to do is look at the entire set of parentheses as a single term and realize that each of the two terms has an x minus 5. And so this very clearly comes under the heading of factoring and GCF. Most of you made the error in assessments of distributing this. This is not a distribution question. What you're doing is you are removing a GCF of x minus 5 from each of the terms, and what you are left with in this case is an x. And what's strange about this is there doesn't appear to be anything, but of course there is always a 1, and so what's left on the other parenthesis is an x plus 1. Okay, now we're going to move into, again, factoring of trinomials. And so trinomial factors by producing two binomials very quickly through the process. To get the x squared, we know it has to be x and x. To get 10, 5 times 2 or 10 times 1, we know that the signs are going to be the same, either plus plus or minus minus. In this case, they're going to be both minus. And the last thing to determine is which of these pairs of factors are going to produce minus 11. Hopefully it's obvious that that's going to be the 10 and the 1. Okay, procedurally, same thing for all of the trinomials. And so x and x, I know that one of them, the signs are going to be different. It's going to be a plus and a minus. In this case, it doesn't matter which parenthesis I put it in because I've got only x's. Factors of 18 that are going to give me 3. So I have 9 times 2, 18 times 1, and 6 times 3. 6 times 3 is what we're after. We need a minus 3x as the middle term, so I'm going to say minus 6 and plus 3, and that will give us the correct middle term. Okay, now hopefully I can wrap this up in the next 5 minutes. Let's have a quick look ahead. Yep, so last page, 5 minutes to go in the video. Okay, same procedure here, only added level of difficulty in this case, because we have now got factors for the first term as well. So to get 3x squared, the good news in this case is that it's just 3x and x. Those are the only factors. And the bad news, of course, is that we've got to be careful which term is multiplied by 3. So it is an added level of difficulty. We know that signs are going to be different, but I can't just put a plus or a minus in because it will matter where the minus goes. So I do know that I'm going to have 1 plus and 1 minus. I now need to look at the factors of 12. 12 and 1, 6 and 2, 3 and 4. And I have to look at which one of those are going to combine with 3x and x in order to be able to get me my middle term of 5x. So factors of the first and last in order to get the middle. Okay, so in this case, if I do 3 times 3 is 9, and 1 times 4 is 4, 9 and 4 can combine to give me 5. So I need 3x times the 3, and I need this 1x to be multiplied by the 4, and that is going to allow me with the answers of 9x and 4x to get to 5x. I need this to be positive, plus 9x minus 4x will give me my plus 5x. Okay, and then last of the trinomials in this form. Again, trinomial, once again open two sets of parentheses. This time we're going to work it the other way. The only way to get 1 is 1 times 1. Signs are going to be the same, either plus plus or minus minus. In this case, we know for sure that they're going to be plus plus, and so this is relatively straightforward. The last thing we need to determine are what are the factors of 9x squared. So we have 9x and 1x, or 3x and 3x. Which of those are going to combine to give me my middle term of 6x, and hopefully you can see that it's 3x and 3x. Okay, 3 minutes to go. This is what is known as a difference of two squares, so it's a binomial, only two terms. If you recall, it factors just like a trinomial, x and x in order to get the x squared, 1 and 1 in order to get the 1. Signs are going to be different, but we make sure one is a plus and one is a minus to ensure that they cancel out and we do not get a middle term. Okay, and now we have a factor completely, and really what that just means is remove a GCF first and then have a look. Could be a binomial afterwards, could be a trinomial, etc., etc. And so what we're going to do is start by removing a GCF. In this case, both of the terms have 2 as common. And then the trick of this is to then look inside the parenthesis, and what you should hopefully recognize is that inside the parenthesis we have got a difference of two squares, a binomial. So you must leave the 2 outside. It doesn't affect the factoring, but it is part of the answer. And so here I'm going to put y and y. To get 9, I must make sure they're the same, so I use 3 and 3, 1 plus and 1 minus. Okay, last question. Again, look first for the GCF. I can remove a 3. I can also remove an x. That is going to leave me with x squared plus 5x plus 6 in this case. Left inside here is a trinomial, and so I now need to factor out that trinomial, leave the 3x outside, ignore it, but it is part of the answer. To get x squared, I have x and x. Signs are going to be the same, they are both positive. I can fill that in now because the two x's are the same. What are the factors of 6 that can add to give me 5? And so not 6 and 1, because those the signs are the same, and so that would require that you subtract. In this case, what we're after, of course, is 3 times 2, which multiplies to give me 6 but adds to give me 5. And that is the end of the Polynomials Solutions video.